Hi everyone, my name is Nick Lefevre. Today I'm going to be presenting on some of the most commonly used tools in several phases of the DevOps lifecycle. Throughout this presentation, I want you to keep in the back of your mind a simple concept: automation. The most popular tools in DevOps are focused on using automation for numerous phases of the lifecycle. Okay, now I know we have gone over DevOps previously in the course, but let's do a little refresher. I'll give you 10 seconds. Can you define what DevOps is? 10 seconds starting now. DevOps, as we have discussed earlier in the course, is the combination of software development, dev, and operations, ops. Prior to the introduction of the DevOps philosophy, software development and operations teams were generally kept separate. However, this led to a common dilemma. Customers wanted new features as fast as possible while also wanting systems that are stable and free from outages. This led to developers trying to push out updates faster and faster, while operations wanted to ensure the stability of the system. DevOps was created to resolve this. By integrating both the development team and the operations team, it enables the rapid deployment of high quality software that meets user requirements while maintaining the stability of the system. Here we can see how software development functioned prior to the introduction of DevOps. Developers write code and test it, then throw it over the metaphorical wall to the operations team, who are tasked with keeping the system stable, running efficiently, and available. As we discussed earlier in the course, there are a lot of issues with this. Namely, the operations team would not have any insight into how the software was developed, and the development team has no idea of how the software is running in production or if it is meeting user requirements. Now let's see how the DevOps lifecycle looks. Unlike in the old way, there is no delineation between the development team and operations teams. All personnel have insights into the development workflow and operations practices for the system. This provides numerous benefits, as we will now see. Using a DevOps approach to software development provides numerous advantages to a team. Here are some of the most significant. Improved collaboration. Integrating development and operations teams fosters a culture of communication and collaboration. As we saw earlier, siloing the development and operations teams creates tremendous amounts of confusion and inefficiencies. Developers are unaware of how their code is performing, and the operations team must expend significant effort if there is an issue to resolve it, since they lack insights into the development process. By integrating the two teams together, it solves most of these issues while also improving future releases, since additional feedback from both teams can be combined. Rapid delivery. Integrating the teams also enables rapid delivery of software. With the additional feedback from the operations teams, developers can release higher quality software faster. This allows for the team to respond faster to customers' needs and hopefully develop competitive advantages in their industry as a result. Reliability. Software developed using DevOps has significantly improved reliability. Techniques such as continuous integration, which I will dive into soon, ensure that errors are caught as early as possible, deployment errors are avoided, and the effects of new releases are known prior to their production release. Combined, all of these result in software that is significantly more reliable than software developed without using DevOps. Scale. DevOps allows for software development and deployments to support increased users, workloads, and complexity. This stems from the constant use of automation for code compilation, testing, and deployment, alongside constant communication between the team members. Now that we have refreshed our memories on DevOps and its benefits, let's take a look at some of the most commonly utilized tools in the DevOps lifecycle. We'll start by looking at tools used in the code, build, and release phases. The first phase of the DevOps lifecycle is the code phase. As implied in the name, developers in this phase write, modify, and review code to create new features, fix bugs, and improve the software. As developers reach milestones in their code, they commit the code to a central version control systems repository. Here, the main tools revolve around an integrated development environment, IDE, and version control systems. The IDE a developer uses is generally based off of preference and need. For example, a developer that needs multi-language support for their project will need an IDE that supports multiple languages. Other developers might only need a single language IDE. Microsoft's Visual Studio Code is arguably the most popular multi-language IDE currently available. Popular single-language IDEs include Eclipse, IntelliJ for Java, and Xcode for Swift development, which is the language iOS apps are written in. While the IDE that the developer or team uses can vary greatly, for version control systems, the most widely utilized is Git combined with GitHub. Git is an open-source distributed version control system, and GitHub is a web-based platform owned by Microsoft. Developers work locally in a Git repository and then push their changes to GitHub. This allows other developers to work with their code. When a developer wants to propose changes to a project, they can create a pull request in GitHub, which allows for other developers on the project to review and discuss the changes before accepting or rejecting them. This workflow should be very familiar to everyone now that we have completed Project 2X. Okay, now that we have seen the tools utilized during the code phase of the DevOps lifecycle, let's now look at some of the most popular tools used in the build phase. As developers are working through their new code for the new feature or bug fix, they build the code into deployable artifacts. This is done for several reasons. First, it is necessary for dependency management. The build tool fetches the necessary libraries from repositories or package managers. Secondly, when a developer creates a new build of their code, the tool conducts automated tests, such as unit tests and integration tests, ensuring that the code still functions correctly with new changes. Lastly, by using a build tool, it makes versioning and release management simpler since it automatically advances the build number each time. This makes it very easy to see a history of changes to the code and simplifies rolling back the version if there are issues. Here I have listed two of the most popular build tools for Java development, Apache Maven and Gradle. Maven uses an XML file called a project object model POM file to manage a project's configuration and dependencies. There are a ton of plugins for the POM file to add new features such as auto-generating documentation and running tests, among others. Maven's use of the POM file makes it really easy to manage dependencies, and I really enjoy using it professionally. Gradle's focus is on the use of the Groovy language to define build scripts, which allows developers to script build tasks, dependencies, and configurations. It also has a very nice incremental build process, which only rebuilds what is necessary each time, saving tremendous amounts of time when building larger projects. Okay, now that we have seen some of the most popular tools used in the code and build phases, let's see how the new changes are deployed in the release phase. Arguably the most popular release tool in DevOps is Jenkins. It is an open source tool that automates the build, test, and deployment processes of software projects. It does this by defining and executing build and deployment jobs based on predefined configurations. Jenkins seamlessly integrates with the team's GitHub repository, enabling continuous integration and continuous deployment (CI/CD) practices. With this integration, every time a commit is made to the repository, Jenkins can automatically trigger the build, test, and deployment of the code without any manual intervention necessary. This CI/CD automation ensures that code changes are continually integrated, tested, and deployed as part of the development workflow, leading to faster and more reliable software delivery. Here is how continuous integration looks visually. Generally, when a new feature is required for the software, a developer will create a new branch within the repository. This branch, called a feature branch, is where the developer will store any code changes they make. As developers commit their code to a feature branch in the source control system, in our case GitHub, Jenkins, or another continuous integration service are automatically triggered, starting with the build process, where the new code changes are compiled and unit tests are executed to ensure the functionality and integrity of the new code. This allows for the identification of any potential errors in the new code immediately. By catching issues early, it ensures that the stability of the system is maintained. Thus, merges from feature branches into the main branch can be done seamlessly without fear of introducing errors. Now, let's wrap things up. Here's what you should take away from this presentation. Teams that use DevOps must be able to communicate and collaborate together. Since DevOps breaks down the old walls between the development and operations teams, Both must be able to work together. This reminds me in many ways of the Agile Manifesto, where it said that people were the most important element. The same is true in DevOps. By working together, the team is able to produce a much higher quality product. Number 2, tooling for efficiency. The choice of tools in the code and build phases is crucial, especially when it comes to selecting the right integrated development environment, version control system, or build tool. The choices vary depending upon the programming languages used, but popular options for Java development include Eclipse or IntelliJ for an IDE, Gradle or Maven for build tools. Git and GitHub is generally the version control system of choice in most teams. Jenkins, the versatile enabler. In my opinion, one of the most versatile and popular tools is Jenkins. By utilizing it, you can automate much of the code and release phases from building and testing to deployment. Jenkins allows your team to streamline the development pipeline and realize efficient, reliable software delivery. This concludes my presentation. Thank you for coming.